Right now, Saturn is losing its rings, not in some distant future, not over the next few billion years. Right now, in this exact moment, invisible rain made of ice and rock is falling out of the rings and down into Saturn's atmosphere, vanishing at a rate fast enough that scientists watching the process unfold have started using an uncomfortable word to describe it: ephemeral. For centuries, humanity assumed Saturn's rings were simply part of the planet, as old and as permanent as Saturn itself. A cosmic decoration installed at the birth of the solar system and left untouched ever since. Generations of astronomers looked through their telescopes at those impossibly thin, impossibly bright bands of light, and saw something eternal. They were almost certainly wrong. And the strange part is, the closer scientists look, the less they agree on exactly how wrong. Because right now, in 2026, there isn't one answer to where Saturn's rings came from. There are several, actively competing, actively colliding with each other in scientific journals, each one built on real data, each one explaining some things beautifully and leaving others unsolved. Some of the newest ideas even threaten to overturn the very method scientists have used for years to guess the ring's age in the first place. This is the story of how one of the most photographed objects in the entire solar system, something children draw before they can spell the word astronomy, turned out to be one of its deepest, most stubbornly unresolved mysteries. And it starts with a discovery so strange that when scientists first confirmed it, using data from a spacecraft that spent 13 years living inside the Saturn system, they weren't sure they believed it themselves. The spacecraft was Cassini, and from 2004 to 2017, it did something no mission had ever done before. It lived alongside Saturn, orbit after orbit, close enough and long enough to actually weigh the rings, to taste what they're made of, to watch them breathe. What Cassini found broke the old assumption almost immediately. The rings, it turned out, are astonishingly pure. More than 95% water ice, nearly free of the dark, rocky contamination you'd expect to build up over billions of years of being sandblasted by space debris. Out in the vacuum between the planets, tiny fragments of rock and dust called micrometeoroids are constantly raining down on everything in their path. And over enough time, that constant bombardment darkens icy surfaces the way exhaust slowly darkens fresh snow beside a highway. Saturn's rings didn't look darkened, they looked almost new. Scientists ran the math, and it led them somewhere nobody expected. If the rings had truly been sitting there, exposed to that steady drizzle of cosmic grime, since the birth of the solar system 4.5 billion years ago, they should be far dirtier than what Cassini was seeing. Instead, the evidence pointed to an age of just a few 100 million years, perhaps as little as 100 million. In planetary terms, that's not ancient, that's practically brand new. Saturn could have existed for over 97% of its life with no rings at all, only to acquire this famous halo sometime around when dinosaurs were still walking the Earth. That single result rewired an entire field. If the rings weren't primordial, something had to have made them recently, something violent enough and close enough to scatter that much fresh, nearly pure ice into orbit around Saturn in a geological instant. And that question, more than anything else, is what scientists have spent the years since trying to answer. One of the boldest attempts arrived with a name that sounds almost too poetic to be real science: Chrysalis. The idea, refined and presented again at a major planetary science conference in the spring of 2026, proposes that Saturn once had another moon, roughly the size of its existing moon Iapetus, nearly 900 miles across. For a long stretch of Saturn's history, this moon, Chrysalis, orbited quietly alongside its siblings. Then, through a slow accumulation of gravitational tugs from the other moons nearby, its orbit began to change. It drifted closer to Saturn than it should have. Every planet has something called a Roche limit, an invisible boundary in space where a planet's gravity becomes strong enough to overpower a moon's own ability to hold itself together. Cross that line, and a moon doesn't crash into the planet in one dramatic impact. It gets torn apart first, stretched and shredded by tidal forces, into a widening trail of debris, the same way pulling on two ends of a piece of dough eventually rips it in half. According to this model, that's exactly what happened to Chrysalis, somewhere between 1 and 200 million years ago. Most of the wreckage fell straight into Saturn, swallowed by the planet's atmosphere without a trace. But a fraction, one relatively small but crucial fraction, stayed in orbit, spreading out into a thin, glittering band of ice that would eventually become the rings astronomers still study today. Here's the detail that made scientists sit up. This same violent event might also explain something else about Saturn that had puzzled astronomers for decades, entirely on its own: the planet's tilt. Saturn spins at a noticeable 26.7-degree angle relative to its orbit, a lean nobody could fully account for. If a large moon-sized object were torn apart nearby in a relatively recent cosmic instant, the sudden shift in gravitational balance could plausibly have knocked Saturn's spin axis out of alignment at the same time it seeded the rings. One catastrophe. Two long-standing mysteries. It's an elegant idea. It's also not the only one. Because while the Chrysalis hypothesis was gaining traction, a separate team of scientists was independently chasing a different question entirely, and stumbling into a version of the same answer through a completely different door. Their starting point wasn't the rings, it was Titan, Saturn's largest moon, and one of its strangest smaller companions, a tumbling, irregularly shaped moon called Hyperion. Hyperion has always been an oddity. Instead of a smooth, rounded shape like most moons, it looks almost like a loosely packed pile of rubble, spinning chaotically rather than settling into the calm, locked rotation most moons eventually fall into. For years, its strange orbit, gravitationally locked to Titan in a precise 4-3 rhythm, was simply treated as one more quirk of the Saturn system. Then a team led by researchers at the SETI Institute started asking a more pointed question: how old is that lock between Titan and Hyperion, really? Their answer, published in early 2026, was unsettling in the same way the ring data had been. The gravitational relationship between Titan and Hyperion appeared to be only 400 to 500 million years old, not primordial, not something that had existed since the moons first formed, something comparatively recent. That single number forced the team to ask an even bigger question. What if Hyperion wasn't simply an old, oddly shaped survivor of the early solar system? What if it was debris? Their proposed answer reads almost like a chain reaction. They suggest that Titan wasn't always alone out there. An additional mid-sized moon, a kind of proto-Hyperion, may once have orbited between Titan and the more distant moon Iapetus. As Titan's orbit gradually expanded outward over time, something it's still measurably doing today, the system eventually became unstable. That extra moon was thrown onto a chaotic path, and in the researchers' simulations, it frequently ends the same way, colliding with Titan itself. In this model, the strange, elongated moon we now call Hyperion isn't ancient debris from the solar system's birth. It's the wreckage or a byproduct of that collision, a rubble pile stitched together from fragments left drifting near Titan's orbit after the impact. But the researchers didn't stop at Titan and Hyperion, because a collision violent enough to reshape one moon's orbit doesn't happen in isolation. Their simulations suggest the same upheaval could have rippled outward through the rest of the system, destabilizing smaller inner moons through a cascade of gravitational resonances, triggering further collisions and reaccretions among that debris. And that debris, the researchers argue, is a plausible source for the very same ring material Cassini had already dated to a comparatively recent age. Two separate teams, two very different starting points, one chasing the mystery of a hypothetical shattered moon called Chrysalis, the other chasing the mystery of a strange 400-million-year-old orbital lock between Titan and a rubble pile moon named Hyperion. And both of them, independently, arrived somewhere disturbingly similar. Saturn's rings are young, and something catastrophic happened to the Saturn system relatively recently in its 4.5-billion-year history. For a moment, it looked like the field was converging on an answer. Then the ground shifted again. Because the entire foundation both theories were built on, the idea that clean, bright ice automatically means young ice, turned out to rest on an assumption that not everyone was willing to accept without a fight. A separate group of researchers went back to the core physics of what actually happens when a micrometeoroid slams into a ring particle, and they found something the original darkening argument hadn't fully accounted for. These impacts happen at extraordinary speed, fast enough that the tiny particles striking the rings don't just leave a dark smudge behind. They vaporize on impact, flashing to temperatures approaching 18,000 degrees Fahrenheit in an instant. That detail matters more than it sounds like it should. If incoming material vaporizes rather than simply sticking and staining the ice, the entire logic connecting cleanliness to youth becomes far shakier. A ring system could, in theory, sit exposed to billions of years of micrometeoroid bombardment and still look relatively clean, if the darkening material is being blasted away or processed differently than the original models assumed. In other words, the very same purity that convinced scientists the rings must be young might not prove that at all. A separate 2026 study went even further, questioning not the physics of the impacts themselves, but the deeper assumptions baked into how scientists calculate the ring's so-called exposure age in the first place. The math depends heavily on estimates of how material actually moves and mixes within the rings over time, whether fresh ice from deeper layers gets continually stirred up and exposed at the surface, refreshing the ring's appearance without requiring the entire system to be young at all. Change those assumptions, and the calculated age changes with them. The unsettling implication is this: it's possible Saturn's rings are exactly as young as the leading theories suggest, freshly created from a shattered moon sometime after the age of the dinosaurs began. It's also possible there's something far stranger, ancient material as old as Saturn itself, kept perpetually looking young by a process scientists don't yet fully understand. Nobody currently has enough evidence to rule either possibility out completely. That's the strange place this mystery sits in right now, in 2026. Not solved, not even close to fully solved. Instead, split across multiple serious, evidence-based hypotheses that don't fully agree with each other, built by different teams studying different pieces of the same enormous, disintegrating puzzle. What almost everyone agrees on is stranger still: whatever their true age, the rings are actively dying. During its final orbits before deliberately plunging into Saturn's atmosphere in 2017, Cassini flew directly through the gap between the planet and its innermost ring and detected something scientists now call ring rain, a steady stream of charged ice particles raining out of the rings and down into Saturn's upper atmosphere, dragged inward along invisible magnetic field lines. Later observations from telescopes on Earth confirm the rings are losing a significant amount of mass this way, continuously, right now, at a pace that some researchers estimate could see the most visible parts of the ring system largely gone within a few 100 million years. Which means that whatever violent event actually created them, whether it was a single doomed moon named Chrysalis crossing an invisible gravitational line it could never survive, or a cascading chain of lunar collisions that reshaped Titan, birthed Hyperion, and scattered debris across the inner system, Saturn's rings were never meant to last forever. They may be a temporary, breathtaking accident, a structure that exists for what amounts to a cosmic blink of an eye compared to the 4.5 billion years Saturn itself has already quietly endured. There's something worth sitting with in that. For as long as humans have pointed telescopes at the night sky, Saturn's rings have felt like a fixed point, one of the few truly permanent-looking wonders in a universe defined mostly by change on timescales, too vast to notice. And it turns out that permanence was always an illusion, a brief, glittering moment in a much longer, much stranger story that started with the death of at least one moon, whose name and shape and final decades we may never fully reconstruct. Right now, somewhere above Saturn's cloud tops, unimaginably small fragments of that ancient catastrophe are still falling, quietly, invisibly, exactly as they have been since long before any human being was alive to look up and wonder where the rings came from. We may finally be closing in on an answer, but the honest version of this story isn't that scientists have solved it. It's that they've finally gotten close enough to see how much more complicated the true answer actually is, close enough to watch two brilliant competing theories collide, and close enough to realize that the very ring of light so many of us grew up believing was eternal is in fact quietly disappearing while we argue about how it was ever born at all.